So relative to the top, this will be my Y, and this will be my X, and this will be my rotation about Z. Okay, so section AA is the cross-sectional view, right? Section A is a cross-sectional view, right? And then we view it this way, okay? And they told us this is equal to 100 millimeter. And this is also 100 millimeter. So that is the link between section AA and the top direct. So visualization is critical, okay? You need to know your planes very well. So like before, now this question did not tell you, okay, did not mention like the one before that we guarantee, all right, the one before, what did it say? It states, deliberately, it states this statement that simplify our analysis. Fully brace against buckling about the what? YY axis. Okay. This question, nothing. Okay, this question, nothing. We don't have that information at all. Okay, so if we don't have that information at all, we have to check. I repeat again, if we don't have information, we have to check. Okay, now given to us, okay, the ends, okay, given to us, the end of the truss, the ends of the structure are both what? Pinned. Okay, they're both pinned. So when that's the case, right? When pin at both ends, we have pin at both ends. We have this situation now. Right? We have pin at both ends, right? So we have pin at both ends, right? And then we are going to make the statement that LE is equal to L, okay, which is equal to what? 3 meters for both, right? For both XY plane, okay, and also our what? Our XY plane is one way of buckling, and another way of buckling is the wait. I'm having, so we have buckling can occur this way, and then if I were to look on Y, and both XY and XZ okay, and XZ, is it XZ? Hold on, I'm having a bit of a brain fart down here. I need to sketch this out, okay? I need to, I know one is about R. So if I will view this in, okay, I'm going to sketch this out. Okay, so if we have a structure like this, and then we have our loads applied here. And then I know I call this direction my X. And I know this is my Y. And this is my Z, right? Maybe I draw the orientation wrongly. X, this is my Y, X, or this direction is my Z, or does not matter. So X, Y, right hand rule, Z. If I view on the side, if I view on the YX plane, if I view Y and Z down here, and if we were to draw this cross section, the cross section will look like this. So this is my Z. So I've drawn my cross section wrongly. Okay, so I will redraw this. So to redraw this, basically this. Now this will be thicker. Yeah, this will be thicker, right? And this side will be thinner. Much better now. Okay. I mean, if I were to draw the ends, you can extend the ends. Okay. If we want to draw the ends further out. Okay. Right. So we know that we have a load down here. Right, we have a load down here. So we know that we have a load down here as P. So buckling can occur on the XY plane. Okay, so when XY plane is about the Z axis. And now buckling can also occur on the XZ plane, okay, XZ plane, which is about our Y axis. Right? So buckling can occur on those two planes. But we don't know which plane is more effective. Okay, we don't know yet, or which is a weaker plane, right? So now if we were to that's where it's critical, right, to know your axis, okay, to know the axis, okay. So now by looking at the cross sectional area, right, by looking at the cross section, so let me do something simple. Let's do both and then we compare. Okay, let's do both, then we compare. So we are going to look at our XY plane. So if we were to look at XY plane or buckling, I'll put down here. Okay, if we look at XY plane, is buckling about Z axis, right? So if we were to sketch now, this is our X, this is our Y, and this is rotation about Z. This is how the structure will look like. And we know from the centroid to here, our applied load. Okay, so this is our P and P down here. Okay, So we know that this will be about our Z, the buckling will occur. So I'm going to sketch the buckling. Okay, so buckling will occur this way. So when that's the case, we know that this is going to be I what? IZZ. So when it's IZZ, this will be the width, and this will be the depth. Okay, this will be the depth for IZZ. Okay, so the width is 50. The depth is 100. Power of 3, right? Divided by 12. So the outcome of this is 50 times 100 power of 3 divided by 12 is equal to 4.166. 7 times 10 to the power 6 millimeter to the power 4. This is equal to 4.1667 times 10 to the power minus 6 meter to the power 4. Okay. Then we're going to look on a different plane. Now, when you look at this, we know that this is under eccentric buckling, right? Because we have a distance E, which is equal to 0.15 meters. Is it 0.15? Yep. So we know that this distance from here to here is 0.15. Okay. So the next plane that we would like to look at is we're going to look at the exact plane. What are we doing down here is we are trying to identify where buckling will occur. Okay. So next, we look at exact plane. So this is exact plane. Right, and then you have rotation about y. So when you look at that, now the structure look like this. And we got some hidden feature over here, right? And this is the geometric centroid. And now if you were to look at P, is acting directly at the geometric centroid, right? So we know that now this become centric buckling. Why is centric buckling? Because E is equal to what? E is equal to 0. And if we were to buckle, the buckle will be in this direction. Hey, wrong color. The buckling will be in this direction. And this direction corresponds to Ry, rotation about Y. So Iyy will be, so if we look at YY now, so I'm going to use a different color for YY, right? So YY, if for YY now, this will be our what? So YY, this will be our width. And for YY, this will be our depth. Okay. So Iyy, the width is 100. The depth is equal to 50. Power 3 divided by 12. Okay. So 100. So it's equal to 1.0416. 1.0417, sorry, 417 times 10 to the power 6 millimeter 4. And this is equal to 1.0417 times 10 to the power 6 meter 4. Okay. So we know on the left hand side is what we call our XY plane, and XY plane is eccentric buckling. On the right hand side is centric buckling, and over here, this is buckling about the y-axis. Right, that is buckling about the y-axis. So we are given that the ends of structure are both pin. So regardless of whether is it XY plane or YZ plane, they are both end what? Over here is also both end pin. Okay. So the weaker axis, right? If both F and pin, i.e. LE is equal to what? Both end pins LE is equal to 3 meters. LE is also equal to what? 3 meters. So with both end pins, right, the same plane, at the both planes, and the second moment of area is smaller. If we look at the function, or we look at the critical load, is equal to pi squared EI over LE squared, right? So LE are both the same, right? IZZ is smaller in IYY. So IYY has the smaller IYY has this IYY has the smaller value. Therefore, okay,